Hey there, in this video we're going to try a quick example to show some of the utility of NumPy arrays. So I've already imported NumPy as NP before doing anything else in this notebook. So we already have NumPy imported just like you will in your own copy of the notebook. And our example here is we want to do a little bit of a kinematics calculation using the equation y is equal to y naught plus v naught t plus 1/2 at squared. Where we have some initial values for y naught, v naught, and a, and we want to calculate y as a function of time. So the way we can do this is we want to make an array of time values that represents every time I care about. In an upcoming video, we'll learn how to quickly calculate arrays following some kind of pattern, but for now we'll just do a hard-coded value of time values. So we're going to do numpy.array, and we'll build it out of a list. Let's do a time 0, 0.1, 0.2, 0.3, 0.4, and let's end with 0.5. Okay, so now I want to calculate an array y that's going to be based on some constants and t. So let's enter in those constant variables. We could just plug in the number as we write our code, but it's much better form to use variables. Even though maybe it feels like a waste, like I could just type in 0, why do I need y naught? A couple reasons for this. Most importantly, it makes your code much more readable. It will resemble the kinematics equation when we type it out, and number 2, it makes it easier to make changes. You could just come back to the same cell and change the value of y initial, for example, without having to figure out where it was in the equation. So we're going to do y initial equals 0, v initial is equal to 10, and the acceleration will be equal to negative 9.8. And now we can type out our kinematics equation. And the beauty of using arrays is what we're going to type is going to look an awful lot like the original equation. We're going to type y is equal to y initial plus v initial times t, don't forget about be explicit with your multiplication, plus 1/2 times a times t squared. And that's really all it'll take to fill in the array y. And now what we could do there is, once we're done, we can print the value of y. And we have now calculated the y position as a function of time for all of the times that we had coming in the original array t. And it did all of this simultaneously for us, because when you work with arrays, it works element by element. And even if you're multiplying by a constant, what it'll do, like right here, is it'll multiply each element by that constant, element by element. So we can effectively write our equations just like they would look on paper, and we'll get a result that is calculated in incredible speed for us.